Hello everyone, I'm Dimitris Brodimas. I'm a researcher at IPTO, Independent Power Transmission Operator of Greece, and I'm going to present you the Smart 5 Grid project. It's a project from the same family as 5GASP, the ICT41 project. It was, and it is still 3 years. The duration of the project was 3 years. We did get an 4 months extension, and the overall budget of the project was 8 million euros. Okay, here's a glimpse of the consortium. You can see a lot of partners from the industry, from the telco industry, especially with the two main network operators of Greece and Bulgaria, the TSOs and DSOs of the Greek, Bulgarian, Spanish, and Italian distribution and transmission systems, along with academia and several SMEs. The main objectives of the project was the creation of an open network application repository, something similar as in 5GASP, a creation of an automatic testing and validation framework, the VNV framework, for NFVs and, of course, microservices, and their testing and deployment of this platform, if you'd like, over, along with the 5G itself, over 4 advanced real-life demonstrators. Okay. Here you can see our architecture, especially the top part is the most important one, with the OSR and VNV components. The OSR, as I mentioned, the developer can register the network applications and the NFVs in order to make them available for the rest of the user of the platform to download it, manage it, and of course deploy it on top of the infrastructure. And of course find third-party components from those NetApps to deploy them all together. Next, the VNV framework that performs verification and validation processes, the verification for syntax errors in the applications and the descriptors, along with the validation that performs several tests of those applications on real-life infrastructure. Finally, the architecture is completed with the MNO framework that is responsible as every orchestrator to deploy and handle the lifecycle management of those applications. Those NetApps were deployed in 4 different demonstration sites, one in northern Greece, one in Bulgaria, one in Italy, and one in Spain. Those network applications and subsequently use cases were the first one for automatic power distribution grid fault detection. When we have a fault in the telecommunication network of the power grid, we need to somehow resolve it and send the issue at the control center. The second one regarding the remote inspection of automatically delimited working areas at distribution level in order to guarantee the safety of the workers inside the substation. Use case 3 about millisecond level precise distribution generation and control in order to integrate as much as possible renewable energy resources and monitor their operations. And finally, use case 4, real-time wide area monitoring that deploys and operates some very advanced IoT devices at the edge of the transmission network in order to monitor the power distribution and control it. Okay, and those 4 NetApps and use cases are already mounted on 5GASP's common repository for all the ICT41 marketplace. Some insight for IPTO's use case and demonstration. The business goal behind this demo is that the high stochasticity introduces issues in the reliability and security of the transmission system. So we need a real-time wide area monitoring framework in order to monitor and control the energy grid. This NetApp could also provide some information and strategies to the TSOs in order to operate their grid. So we created such a wide area monitoring tool that was comprised by the virtual phasor data concentrators, the VPDCs, that concentrated measurements and data from the phasor measurement units, some advanced IoT, as I already mentioned, deployed on each side of the grids of IPTO and ESO, the two TSOs of Greece and Bulgaria. Finally, those PMUs with the PDCs were connected via 5G communication network. So this cross-border scenario implies a direct communication between those devices, the PMUs and the virtual PDC via 5G networks. The KPIs that could be reached via 5G could not be compared with the previous generation of wireless networks. It was better. And of course, with the optical fiber, we do not intend to substitute the optical fibers from the transmission networks, as it is inherently designed to work with them, but support the last mile operation at the IoT level inside the substations. Here is a high-level architecture with the two interconnected system of Greece and Bulgaria with the PMUs that were connected via 5G gateways to the network system. And then you can see the different VNFs comprising the total NetApp of this specific use case with a VPDC, a monitoring service, and an advisory service that sends through MQTT messages, some alerts to the two TSOs. The MEC orchestrator was provided by Nearby One, while Kubernetes and Helm, probably not Docker, were used in order to deploy the applications. The VPDC, as I mentioned, gathers and aggregates the measurements. The monitoring service visualizes them in order to provide to the controller of the system a human-friendly API, user interface, basically, and the advisory service in order to indicate that there is a problem in the grid to the two TSOs. Okay. Here are two pictures of the monitoring service with the phasors of voltage and current, and the time series of the current during a specific time frame. Those are real measurements from the real power grids. Okay. Here is a view of the substation, where we deployed our equipment. It's in Thessaloniki. Here is the equipment itself, the PMU, the gateway, the 5G gateway, the GPS antenna that timestamps the measurements taken in the grid, and inside the substation, how the connectivity is. And a diagram of what I just explained. We also implemented 3 different scenarios with a private APN roaming scenario and another private APN for Thessaloniki and Blagoevira, the two substations. And actually, that's all. I don't know if there are any questions. Also, our final event is on the 9th of April. You are welcome to join. It is in Brussels. So, any questions?
Thank you.
Thank you very much.